So a three-phase star connected 1000-volt alternator supplies power to a 500 kilowatt delta connected induction motor. If the motor power factor is 0.8 and its efficiency is 0.9, then what is the current in each alternator and motor phase respectively? So here basically an alternator is supplying, a three-phase alternator is supplying power to a three-phase delta connected induction motor, so which is rated at 500 kilowatt. The rating of induction motor is 500 kilowatts and it is operating at 0.8 power factor with efficiency of 0.9. So this is the star connected alternator and this is the delta connected induction motor. So an alternator is supplying power to delta connected induction motor. So let us complete the winding diagram. So alternator is star connected and induction motor is delta connected. So like that you can connect the windings, the respective phase windings. So this is we have connected this alternator with a delta connected induction motor. Now the line current which is supplied by the alternator will be equal to the line current of this three-phase induction. Input will be the input to the induction motor, three-phase induction motor. So output line current supplied by this alternator will be equal to the input line current to the induction motor. So this line current we will have to calculate IL, and we will also have to calculate the respective phase windings of star connected alternator and delta connected induction motor. So this is the current, per phase current, which is flowing in delta connected winding of three-phase induction motor. So this current is basically the phase current. So phase current is basically line current divided by √3 for delta connection, and here for the star connection the phase current will be same as the line current. So this is the phase current, which is nothing but line current only, because for a star connection line current and phase current both are same. So IPH represent the phase current, IL is basically the line current. So once we calculate the line current, we can calculate then the phase current, the respective phase current. So here it is given that the alternator is supplying power to a delta connected induction motor and its rating, output rating is 500 kilowatts. So the nameplate rating is output rating. So this is the output rating, 500 kilowatt. So first we will have to calculate the input to the induction motor, power input. So power input is nothing but output by efficiency. So input to the induction motor is output by efficiency, that is 0.9, So power input is induction motor power input is nothing but output by efficiency, that is neta, and here the output is given as 500 kilowatts. So that is the output rating, that is 500 kilowatts. So 500 kilowatt divided by the efficiency of the motor, that is 0.9, will give the power input to the three-phase induction motor. So here it is nothing but, it comes out to be equal to 555.55 kilowatts. So now this is the power input that is taken by this delta connected induction motor. So this input is given as, it is basically three-phase power input, which is equal to three-phase power input, that is equal to, this is equal to, three-phase power input is equal to root 3 times of line voltage into line current into operating power factor of the motor. So here this cos phi is the operating power factor, VL is the line voltage, IL is the line current. So here just put the values. Power input that we have just calculated is 555.55 kilowatts. So kilowatt means 10 to the power 3 watts, multiply by 10 to the power 3, convert into watts. So root 3 into line voltage is given as 1000 volt. Line voltage is 1000 volt, and the line current we have to calculate, and the operating power factor is 0.8. So when you solve this, you will get line current is equal to, line current is 231.5 amperes. Oh sorry, this is 401 ampere. So this is the line current which is drawn by the three-phase induction motor. So this is the line current basically supplied by this three-phase alternator at line voltage of, this is the line voltage, it is given as 1000 volt. So now we have calculated the line current which is supplied by this alternator to this three-phase induction motor. Now we can calculate the phase current. Phase current comes out to be equal to, for delta connection, phase current is line current by root 3. So 400 ampere is the line current, and divided by this root 3 will give you the phase current, that will come out to be equal to 231.5 ampere. So this is 231.5 ampere, that is the phase current in delta connected winding. In each phase the current is 231.5 for induction motor, and Here the phase current will be equal to line current because it is a star connection for alternator. So this is equal to 401 ampere. So that is a line current, 401 ampere. So here you can see that option B is correct. B is the correct option. 400 ampere is the line current, which is a phase current in star connected alternator. In each phase 401 ampere and 231.5 ampere for each phase in delta connected induction motor. So here your option B is correct option.